This problem is about finding the temperature of flue gas to avoid condensation of water. Volumetric analysis of a hydrocarbon combustion product shows 8% CO2, 15% water vapor, 5.5% oxygen and 71.5% nitrogen. The combustion product flows steadily through a heat exchanger at 200 kilopascal pressure. Assume each component in the mixer to be an ideal gas. In order to avoid the condensation of water in the heat exchanger, the minimum allowable temperature is, we have the saturated water table, there is vapor pressure in kilopascal and temperature in degrees Celsius are available here for 10 kilopascal, for 20 kilopascal, 30 kilopascal and 40 and 50 kilopascal. The corresponding temperatures are available. These are nothing but the saturation pressure and temperatures. Okay, we need to find the minimum allowable temperature. Fine. So we know the partial pressure of water in the combustion product is equal to total pressure multiplied by the mole fraction. Mole fraction or the volume fraction. That doesn't matter because mole fraction is mole fraction equal to volume fraction for an ideal gas mixture. If it is ideal gas mixture, mole fraction and volume fraction are the same because at a given pressure N is proportional to V or N and V have a direct relation. PV equal to nRT, from that PV equal to nRT, so always V is proportional to N. Okay, now coming back, so partial pressure is total pressure multiplied by the volume fraction or the mole fraction. So we get this is 30 kilopascal. This is the partial pressure of water vapor in the combustion product. That is a flue gas. Okay, the condensation of water happens if the partial pressure is greater than or equal to the vapor pressure. That is, whenever the partial pressure is exceeding this vapor pressure, the condensation starts. So we should ensure that the partial pressure is never greater than the vapor pressure. So what is the partial pressure? Already 30 kilopascal. So the vapor pressure, otherwise we should ensure that this partial pressure is always higher than the prevailing vapor pressure. The vapor, otherwise this 30 kilopascal. Let us check, otherwise we will equate this partial pressure to the vapor pressure. And for this partial pressure, or is for this vapor pressure of 30 kilopascal, the temperature is 69.12. So corresponding to this 69.12, the vapor pressure is 30 kilopascal. And if we operate at a higher temperature, say for example at 75.42, 75.82, the vapor pressure is 40 kilopascal, whereas the prevailing partial pressure is only 30 kilopascal. So corresponding to this 40 kilopascal, the partial pressure is lesser, so definitely condensation won't happen. But at this temperature, otherwise the temperature, if it is slightly higher than 69.12, then condensation won't happen, because at 69.12 the vapor pressure and partial pressure are just the same, whereas the relation is higher the temperature, higher is the vapor pressure. So if you can operate at a temperature say about 70 degrees Celsius, at 70 degrees Celsius definitely the vapor pressure will be say about 31 or so. So vapor pressure is now higher than the partial pressure, so definitely the water will remain as vapor. Whereas if you operate at a temperature say 29, what will happen? 29 corresponding to say if you operate at a temperature say at 68, corresponding to 68 degrees Celsius, the vapor pressure will be somewhere around 29 kilopascal. Vapor pressure is 29 kilopascal, whereas the partial pressure is 30 kilopascal. So definitely the water vapor will start to condense. So otherwise, what is the required temperature? Temperature should be, otherwise the minimum allowable temperature is 69.12. Better to have a temperature higher than 69.12. That is the minimum allowable temperature is 69.12. At that, the partial pressure and vapor pressure are just the same. It's at the verge of condensation, better to be up at a temperature slightly higher than 69.12. So better we can have this as 69.5 or okay, 69.12 also okay, or it should be greater than 69.12. Thank you.